All right, in section 1.7, we are going to take a look at solving absolute value equations and inequalities. So, first, just a little refresher. Our definition of absolute value is the distance from zero on a number line. So, when we are solving absolute value equations, if we have the absolute value of some function equals a number, then we actually want to create two equations. We want to say whatever that function is can equal that value, or the function can equal the opposite of that value. Right? The reasoning behind that is, if we have some function, let's just say x, right? And we say that the absolute value of x is equal to 7. Well, whatever we're plugging in there could actually be positive 7 or negative 7, right? When we're taking the absolute value. That's why we have to create two equations. And it's the same idea if I have the absolute value of something on both sides of the equation. And if I've got the absolute value of a function equal to the absolute value of another function, then we would just say this function equals that function, or this function equals the opposite of that function. Now, note, if we have something like the absolute value of x plus 5 equals negative 7, there are no solutions for that because the absolute value of anything cannot be a negative number. Okay? And when we're solving these, we do have to check for extraneous solutions. So let's go through a few examples. In this first one, and just like we just said, we're going to set up two equations. I'm going to have one equation where I'm taking the whatever's on the inside of the absolute value and just setting that equal to this side of the equation. And then I'm also going to take whatever's on the inside of the absolute value and set it equal to the opposite of the right side. So these are the two equations that I want to solve. So for this one, add 4, divide by 3. And then for this one, add 4, divide by 3. And we get two answers. Now we do need to check in our original equation because we can get extraneous solutions here. So if I plug 10 thirds in, I have the absolute value of 3 times 10 over 3 minus 4. So 3 times 10 thirds would be 10. 10 minus 4 is 6. And the absolute value of 6 is 6. That works. So this is one of my answers. Do the same thing here. So the absolute value of 3 times negative 2 thirds minus 4. So this would be 3 times negative 2 thirds would be negative 2. Negative 2 minus 4 would be negative 6. And the absolute value of negative 6 is 6. It works. So both of these are solutions. All right. Let's try one where we've got absolute values on both sides of the equation. So here, again, setting up two equations, I'm just going to take the inside of the first one equal to the inside of the second one. And then my second equation will be the inside of the first one equals the opposite of the inside of the second one. All right. So to solve the first one, I can subtract x over, subtract 5, get x equals negative 8. And then here, I can first distribute this negative sign over here. So we'll get negative x plus 3. Then add x over, subtract 5, and divide by 3. And we get two answers. Again, we need to check them. So if I plug negative 8 in, the absolute value of 2 times negative 8 plus 5 equal to the absolute value of negative 8 minus 3. We're checking to see if this works. So 2 times negative 8 is negative 16. Negative 16 plus 5 would be negative 11. And over here, negative 8 minus 3 would be negative 11. So the absolute value of negative 11 equals the absolute value of negative 11. This is an answer. And finally here, Plug negative 2/3 in, so 2 times negative 2/3 plus 5. Does that equal negative 2/3 minus 3? So 2 times negative 2/3 would be negative 4/3. Negative 4/3 plus 5 would be 11/3. Then over here, we want to see if that's equal to negative 2/3 minus 3. So negative 2/3 minus 3, that would be minus 9/3. So that would be negative 11/3. So the absolute value of 11/3 does equal the absolute value of negative 11/3. So this is also an answer. All right. So our final equation example here, we've got a quadratic. So it's the same process though. We want to take the inside of this equal to the inside of this, and also the inside of the left side equal to the opposite of the right side. So we've got two quadratics to solve. For both, I'm going to move the x over to the left side. So here I would be subtracting. So x squared minus 6x minus 7 equals 0. And then over here, I would be adding. So I'll have x squared plus 6x minus 7 equals 0. And then we just want to solve both of these. So I think both of these will actually factor. So here we want two numbers that multiply to negative 7 that adds in negative 6. I think that would be negative 7 and positive 1. So this would factor into x minus 7 times x plus 1. So setting those equal to 0, we'll get x equals 7 and x equals negative 1. Then for this one, two numbers that multiply to negative 7 that add to positive 6, well, that's just going to be positive 7 and negative 1. So we'll get x plus 7 times x minus 1, and that would result in answers of negative 7 and positive 1. Now, we've got 4 answers here. We do need to check all of them to make sure that they aren't extraneous. So if I plug 7 in, I'll have 49 minus 7 is 42. The absolute value of 42 equals the absolute value of 6 times 7, which is 42. That works. If I plug negative 1 in, negative 1 squared is positive 1. 1 minus 7 would be negative 6. And if I plug negative 1 in here, I would also get negative 6. So the absolute value of negative 6 equals the absolute value of negative 6. Let's check these. If I plug negative 7 in, negative 7 squared would be positive 49. 49 minus 7 is positive 42. Then over here, 6 times negative 7 would be negative 42. So the absolute value of positive 42 does equal the absolute value of negative 42. That one works. And then finally, if I plug positive 1 in, 1 minus 7 is negative 6, and 6 times 1 is positive 6, but since I'm taking the absolute value of both sides, that one works as well. So we got 4 answers for this one, okay? So now let's transition and take a look at absolute value inequalities. So 2 situations here. If we've got the absolute value of some function less than a value, we want to say, well, that function would have to be just less than that value, but it would also have to be greater than the opposite of that value. For example, right, if we just have the absolute value of x is less than 3, well, we would know that x has to be less than 3, but x would also have to be greater than negative 3 because we're talking about the distance from 0, right? So if I'm saying the absolute value has to be less than 3, that's the distance from 0. So I'm saying if I go 3 in this direction and I go 3 in this direction, we have to be in here, right? The distance from 0 has to be less than 3. So that's between negative 3 and 3. Similar idea if we're talking about some function being greater than a value, right? In this case, we would just need to include all the values less than negative a or the values greater than a. So again, for example, if we take that same thing and say the absolute value of x has to be greater than 3, well, that's saying the distance from 0 has to be greater than 3. So if I go out to 3, I'm saying I want everything past that, right? I want all of this. But then also, if I go to -3, I want everything past -3. The distance from 0 has to be bigger than 3. So I would want all of this and all of this. So let's take a look at that from an inequality perspective, from an algebraic perspective. So this first one fits my first case here, right? I want to say that this 3x plus 3 has to be less than or equal to 6, but also greater than or equal to -6. So I'm going to set this up as a nice compound inequality like this. Okay, now to solve something like this, we just want to get x by itself. So whatever I do to this, I have to do to every part of this compound inequality. So to get x by itself, I would subtract 3. And if I'm doing that, I want to do that to every part. So this is going to then become -9 is less than or equal to 3x is less than or equal to 3. And then divide everything by 3. So here I would get -3 is less than or equal to x is less than or equal to 1. Now, we have been writing our answers in interval notation. So to write this in interval notation, I'm saying I want to start at -3 and end at 1. So I'm just saying, and I am including my endpoints in this case because I'm saying they're both or equal to. So this is how I would write my answer in interval notation. Okay. Now, the next example is the second situation here. We're saying the absolute value has to be greater than some number. So I want to set up two separate inequalities here. I want to say 2x minus 10 has to be less than the opposite of this, and also 2x minus 10 has to be greater than 8. So just get x by itself for both of these inequalities. I'll add 10 over. So I'll have 2x is less than 2, divide by 2, and I'll get x is less than 1. Then here, add 10. So 2x is greater than 18, divide by 2, and I'll get x is greater than 9. So I've got two different intervals here. And I've got x is less than 1. So that means I want all the values from -infinity up to 1. And here I want all the values greater than 9. So I'm going to union that and say I want to start at 9 and go up to infinity, right? Now, I am not including the 1 and the 9 in this problem because it's just less than and greater than. It's not or equal to, right? So let's wrap up this video here with a couple of special cases. So here, we've got the absolute value of 5 minus 9x is greater than -3. Well, an absolute value is always positive. So I don't even have to solve anything here. We're saying that no matter what we plug in here, it's going to be greater than -3 because I know no matter what this ends up being, it's going to be positive. So this problem, the answer is just everything, all real numbers, -infinity to +infinity, because we're saying the absolute value of something has to be greater than a negative number. Right? Well, that's always true no matter what is inside of here. Even if this were -1 million, right, the absolute value of -1 million would be +1,000,000. So our second special case then says the absolute value of some function is less than or equal to a negative number. That is never true. right? We cannot have an absolute value that is less than a negative number because an absolute value will always be either zero or positive. So this has no solutions, right? So that is it for this lesson. The final question is going to pop up on your screen asking you what questions you have.